What exactly is DevOps? Let's take a look. DevOps. Dev for developers, Ops for IT operations. Developers tend to have the following set of responsibilities. They code the application depending on the requirements or the user stories for that sprint. They're going to then build the project to create an artifact or an executable, which can then be deployed onto the server or on the development environment to test their changes. They're also responsible for taking care of testing the entire application, making sure that all the features are working as expected and that none of the features were broken because of the recently introduced changes. If you have a separate quality assurance team, they're going to take care of thoroughly testing the application. On the other hand, IT Ops team would have a different set of responsibilities. They are responsible for deploying the application on the staging or the production environment so that the application can now be used by the customer or the end user. They're also responsible for maintaining the infrastructure required to deploy the application. So they're going to make sure that there are adequate servers and resources to help run the application seamlessly. They'll also constantly monitor the application for application's performance, health, resource utilization, warnings, errors, etc. Now, deploying the application is not an easy task. It's not that you copy the artifact onto your server and it magically works. You have to take care of the dependencies, libraries, configurations that will help run the application. Oftentimes, Ops team are not familiar with these steps, and so they take help from developers. So developers would provide a deployment guide with clear step-by-step instructions on how to deploy the application. The Ops team would follow those steps, deploy the application, and the application would be up and running. All well and good. Until one night, the application crashes, or some of the features would break. That leads to the infamous blame game, where the Ops team would say that they have followed all the instructions in the deployment guide, and if application is still not working, then it is up to developers. On the other hand, developers are going to throw back the blame to Ops team, saying that they have followed the exact steps in the deployment guide, and it worked for them on their development environment. So the blame would go back and forth, waste a lot of time, but the truth is, the mistake could be anybody's. It could be the case that developers missed a step in the deployment guide, or it could be the case that the Ops team haven't followed the instructions well, or maybe it has something to do with the resource allocation, or maybe the Ops team might have installed a different version of software which is unsupported, or actually it can also be a bug in the code. Maybe developers have done a mistake. For example, developers might have written a bad code which constantly consumes the memory to a point that the system would go out of memory and the application crashes. And that may not happen on development environment because they do not run the application long enough for it to crash, because they keep redeploying the application as and when they introduce changes. However, this might happen on production environment where the application would be constantly running for a long period of time. Being a developer myself in the past, it's actually very frustrating to hear something like that from Ops team, because generally speaking, developers are already busy implementing the new features. They have new commitments, they're answerable to their boss, and they're not willing to dig through the old logs which might impact their current project commitments. So they try to avoid these problems by just simply blaming the other party. And same is done by the Ops team as well. But this blame game wastes a lot of time, and a lot of issues would be left unresolved for a long period of time, and so even the release would get delayed for weeks or even sometimes for months, which will lead to customer frustration, and you can guess the consequences of it. It means loss of revenue and reputation for the company. This is the trigger and the starting point for the DevOps movement. So what is DevOps? Anything we can do to improve the team's efficiency, reduce the odds of error during production, improve the communication between teams and encourage communication between cross-functional teams, reduce the release time, or improve the overall process is what is DevOps. And all this can be accomplished with combination of mindset, cultural philosophies and practices, tools and automation. And if you ask me, DevOps has evolved so much nowadays that it has less to do with mindset and cultural philosophies, but more to do with tools and automation. What was initially started off as a mindset shift has now evolved into tools and automation, which we're going to talk about right next. Let's talk about the mindset aspect of DevOps. Before DevOps, there used to be a psychological barrier between developers and IT operations, wherein developers are more focused on writing the code and are not bothered about the environment on which the application would be running. Ops team, on the other hand, are never bothered to understand how the application works, its dependencies, or anything that is related to developer's job. With DevOps, this barrier would be broken, and both the teams would come into common understanding that they actually work together. They now start to believe that they're actually one team. If there is anybody to be blamed in case of an issue, then there is no one to be blamed except themselves. They're going to resolve the issues together as one entity. In fact, in certain organizations, there is no separate developer and operations team. They might call themselves as developers, but they actually do the job of both developers as well as IT operations. Now, this is the mindset aspect of DevOps. Now let's talk about some of the cultural philosophies and practices in DevOps. DevOps encourages to have open communication and collaboration between teams, knowledge sharing between the team members. So developers might have a knowledge sharing session with the ops team, and vice versa. Ops team might have a knowledge sharing session with dev team. Regular meetings with cross-functional teams like testing team, security team, etc. In fact, before DevOps, ops team are never bothered to attend any of the meetings of developers. But now they're actually involved in the entire product life cycle, right from requirement gathering. In fact, they also attend the meeting for requirement discussions, broadening their skill set. So developers might gain some of the skills of operations and vice versa. Ops team gain some of the skills of developers. Use of collaborative tools, which we're going to talk about in just a bit. One thing I should mention is that DevOps is not practiced the same way in every organization. Depending on the scope of the project and kind of technologies they are using, DevOps practices and tools might differ. Developers would be needing a dev environment to test their changes or for their day-to-day activities. Similarly, testing team would be needing a testing environment to thoroughly test the application. And likewise, IT ops team would also need staging or the production environment to deploy the application. In order to get all these environments, we would probably be needing servers. Earlier we used to procure servers and used to maintain them on our own. But nowadays we use cloud service providers like AWS, Azure, GCP. They provide infrastructure as a service, meaning that instead of we maintaining the servers, they're going to do that for us, and they're going to provide resources as services like RAM, CPU, hard disk, etc. The advantage of using a cloud service provider is that it's more scalable, it's more secure, it's also more reliable and cost effective compared to purchasing physical servers and maintaining them on our own. But creating an infrastructure is not just about launching a bunch of virtual machines. We also need to take care of setting up the network configurations, attaching storage volumes, and even configuring other necessary services like databases, etc. So creating the infrastructure consistently across all the teams without making a mistake is actually a very challenging and time-consuming task. To solve this problem, we have Terraform. Terraform offers infrastructure as code, which means it will allow you to create infrastructure by writing code. For example, you can write code saying that you need n number of servers with so and so RAM and so hard disk, and it's going to do just that. It allows us to create similar and consistent environments across all the teams. You can even reproduce the same environment by running the script again. Once you have the infrastructure or the servers, the next thing we want to do is to install operating system. Now all these cloud service providers provide us a ready-made VM image that comes with operating system. So while launching the virtual machines using Terraform, we can choose that image so that the infrastructure or the servers would be created along with the operating system. Or alternatively, you can also use a configuration management tool like Ansible in order to install operating system on the servers. We're going to talk about Ansible in just a bit. Now we have the infrastructure and the operating system. Technically, we can now deploy the application and get it up and running. As a dev team member, you can easily do that because you're a technical person you know all the libraries, dependencies, configurations required to help run the application. However, if you talk about some of the non-technical individuals, like from testing team or from IT ops team, they don't know how to deploy the application, and so they rely on developers to get the instructions. And we've already talked about the consequences of this approach. If the dev team provides a deployment guide, then it can happen that there are not enough instructions on the deployment guide, or it might happen that the testing team or the ops team haven't implemented those instructions exactly how they're supposed to be. Instructions exactly how they're supposed to be. And that would lead to application not functioning as expected, and it eventually leads to the blame game, delay of release, so on and so forth. Hence, to solve this problem, we now have Docker. So this time, instead of deploying the application directly on operating system by installing softwares, configurations, etc., or providing the deployment guide to the other teams, we're going to now create so-called a Docker image. A Docker image is essentially a combination of the code, runtime, libraries, and configurations. It's actually a self-contained package that includes all the necessary dependencies, libraries, and files required to run the application. And using these Docker images, we can spin up containers in different environments. Now, in order to create containers out of these images, we need a platform that supports it, and that's where Docker platform would come into picture. We're going to install Docker platform on top of operating system, and now we would be able to create containers out of the Docker images. A Docker container is essentially a runtime instance of a Docker image. If you're familiar with VMware technology, then Docker image is equivalent of VMware snapshot. And Docker container is equivalent of a running version of VMware snapshot. But unlike a virtual machine, Docker images are lightweight. It doesn't come along with an operating system. Instead, it would use the host operating system. Anyway, that's going to be a topic of another lecture. Now, in general, we may not just be having one Docker image that would have the entire application. If you're following microservice architecture wherein your application would be split up into multiple smaller modules, then you might end up having hundreds of Docker images. Maintaining those Docker images manually is a difficult task. And that's why we have artifact repository solutions like Nexus or Docker Hub. Nexus acts as a centralized repository where development teams can store, share, or retrieve the software artifacts like Docker images. It basically enables easy sharing, collaboration between teams, and even version control of artifacts within the development teams or across the organization. And various teams in the organization are going to pick the Docker images from these platforms, and they're going to spin up containers out of those images. So you might end up having hundreds of containers running. But when you have so many containers running, it becomes really difficult to manage them manually. And that's where Kubernetes comes into picture. Basically, it provides a platform for container orchestration, making it very easy to deploy, scale, or manage the Docker containers from a single dashboard. Without Kubernetes, it's really impossible to manage so many containers. So far we have got a consistent environment across all the teams. We've got the infrastructure, operating system, and we've even got the application up and running. Now, what if I want to install a software or update a software or change a configuration in these environments? Well, we cannot log into every system and do it manually. It's very time consuming and error prone and would be very inconsistent. So to address this very problem, we have tools like Ansible, Chef, Puppet. With Ansible, you can automate various tasks like deploying the application, installing a software, changing a configuration, etc. While Docker allows you to create an isolated runtime environment with application code, dependencies, etc., Ansible, on the other hand, works on top of existing system to perform various tasks on the remote system. We can use Ansible to install the operating system and even the Docker platform. So these are some of the tools used in DevOps to create the environment. We've got a bunch of other tools as well, and we're going to talk about them when we talk about the phases of DevOps, which is coming right next. Let's talk about various phases in DevOps and also understand the different kinds of tools used in each one of these phases. First, we have the planning phase, And this basically involves defining the project requirements, setting up the goals, giving the individual capacity, and deciding on who will do what, etc. And here we might use these tools. We need a project tracking tool like Jira, for instance, which is one of the most popular tools to track the project. Here we might track user stories, bug fixes, etc. And then we have collaborative tools like Slack, Confluence, Google Docs, Microsoft Teams, etc. for messaging between the employees or to manage requirements, share knowledge, collaborate with cross teams, etc. Confluence is like a Wikipedia for an organization. Next, we have the coding phase, and this is where obviously developers would write and review the code. They'll ensure its quality and adherence to the coding standards. And here they're going to use version control system like Git and code repositories like GitHub, Bitbucket, GitLab, etc. And they typically tend to follow test-driven development by writing JUnits or performing any static code analysis using tools like SonarQube. Static code analysis would mean that we would analyze the source code for quality, reliability, and security without having to execute the code. And obviously, not to mention that in order for developers to work on their day-to-day activities, they're going to be needing environment. And we can get that environment using all the technologies we've talked earlier. Next, we have the build phase, and this is where we might use some CI/CD tools. We're going to talk about CI/CD in more detail in upcoming lecture. But one of the popular tools for CI/CD is Jenkins. We also have other tools like Circle CI or GitLab CI/CD that does exact same job. And as part of build phase, Jenkins would actually use some of the additional tools like Maven Gradle to build a project so that we get an artifact or a deployable artifact. And Jenkins will also create a Docker image using the Docker CLI. And with that, obviously we need a place to store the images, and that's where we have Nexus and Docker Hub to host and maintain the artifacts. Next, we have the testing phase. This is where we would do the thorough testing of the application. So here we do regression testing, making sure new features didn't break any of the existing ones. We do acceptance testing. We also do security and vulnerability analysis. We do performance testing, configuration testing, etc. Selenium is one of the popular tools to automate the process of testing the application. Apache JMeter is one of the popular tools to perform performance testing. And once again, in order to test things, we need an environment for testing. And that's where once again we're going to see all these technologies coming into picture. And we've already talked about all of these earlier. Next, we have the deploy phase, which is where we're going to use Jenkins to automate the process of deploying the artifact, or specifically the Docker image, onto the production environment. So once everything is tested and making sure that everything is working as expected, the Jenkins will automatically pick the artifact from artifact repository like Nexus or Docker Hub, and it's going to deploy it onto the staging or the production environment. And once again, we're going to see all the technologies that will help us create the environment. Next, we have the operate phase. So once the software is deployed, the operations team would do their job to manage the infrastructure, troubleshoot any issues, monitor the application. Their main focus is to maintain a stable and reliable environment, making sure of high availability, performance, and security. And next comes the monitoring phase, which involves collecting and analyzing the metrics, logs, tracking the application's performance for health and resource utilization, etc. Basically, operations team will monitor for everything, and if they find any issues, they will escalate it to the relevant teams. Nagios and Prometheus are some of the popular tools for monitoring, and Dynatrace and AppDynamics are some of the tools for performance monitoring. Next comes the learn phase, and here we basically collect feedback from users, stakeholders, and monitoring tools to suggest for any improvements, bug fixes, or even introduce new features with the goal to refine and enhance the software. And the entire cycle now repeats right from the planning phase. It's a continuous process, and new releases would keep happening forever, at least till the point the project gets abandoned. And that is the reason why DevOps logo looks like an infinity symbol, because this process would keep on happening forever and software will evolve and improve every single time. One important point I want to make here, which is also the thing that I've mentioned earlier, is that DevOps is not practiced the same way in every organization. The tools and methodologies would differ depending on the project. But what we've talked so far are the popular ones. If you're not sure what to learn, then learn these popular ones, the ones I've mentioned. Next, we're going to talk about the most emphasized word in DevOps, continuous. I'll see you next. Traditionally, developers used to work on their feature or bug fix, and then they're going to push those changes onto a centralized code repository like GitHub, Bitbucket, GitLab. I'm assuming that you're not familiar with these tools, so I'm not going to use any of the terminologies associated with them. But essentially, developers would contribute their changes, and only at the end of the development lifecycle would all those code changes be merged. In other words, all these code changes would be merged or integrated and make them part of the main code base. Once it's done, assuming there are no conflicts, we would go to the next phase where the testing team would test all the changes, do thorough testing of the application on the testing environment, and assuming that everything went well and that the testing team haven't found any issues, which is very unlikely, we're going to move on to deploy the application onto the staging or the production environment. However, this is the best case scenario, but in all likelihood, you're going to see the following issues. You're going to see integration issues, because when you merge so many changes together in one go, the chances are that you're going to come across with conflicts, meaning more than one developer might have worked on same piece of code, and those conflicts needs to be resolved before proceeding. Or it might happen that changes done by one developer might have negative impact on changes done by another developer. It's also really hard to trace the issues, because when you integrate so many changes together, in case if you find an issue, it's really hard to know which particular change has actually caused the issue. So resolving the conflicts and identifying the root cause of issues becomes more challenging, which might lead to potentially time-consuming and error-prone integration efforts. And worst, if testing team finds any critical issue, then it might even result in delay of release. And even the feedback cycle is longer. Developers will not get to know of conflicts or any bugs until the end phase of the development cycle, and this might lead to longer resolution times and hinder the ability to address issue in timely manner. With DevOps though, we're going to follow a different approach, and here is how it goes. So after the planning phase, developers would start coding. Every developer would contribute their changes onto the centralized repository. And then we have Jenkins, which is a CI/CD tool, would constantly monitor for new commits on the repository. Upon identifying a new commit, Jenkins will initiate a build process to create the artifacts or the Docker image, which would then automatically be deployed onto the testing environment. Jenkins will also trigger automated tests to thoroughly test the application and the changes. And once it is done, Jenkins will notify the reviewers to review the code changes. The reviewers will examine the code changes, provide necessary feedback, suggest improvements, etc. And developers would address the feedback received during the code review. They make all the necessary modifications, add clarifications, or discuss alternative approaches. And this iterative process continues until the code changes meet the required quality standards. Once everything is well and good, once the reviewers approve the code, we're going to go to the next phase, wherein we're going to merge all those changes, or in other words, we're going to integrate all those changes onto the main code base. And before actually merging the changes, we might have a task in Jenkins to perform any of the additional tests or validations before merging the changes. Upon merging the changes or integrating the changes onto the main code base, we might initiate the process of deploying these changes on the production or the staging environment. And once again, Jenkins is going to do the job for us. It's going to build the project, deploy the necessary artifacts on the staging or the production environment, and get the application up and running. Now the process of contributing the code, running automated tests, and eventually merging the changes or integrating the changes onto the main code base is what we call continuous integration. Or more specifically, we also have continuous development, where the developers would continuously make improvements, introduce new changes, and the process of continuously testing the changes with automated tests is continuous testing. What we used to do manually earlier are now bunch of automated tests. And the process of delivering the changes onto staging or the production environment is what is called continuous delivery. We also have often confused term called continuous deployment. The difference between continuous delivery and continuous deployment is very simple. When we manually interfere to allow Jenkins to pick the code from main code base and eventually deploy the application on the production environment, that's called continuous delivery. If we automate this process, meaning that right after we integrate the changes to the main code base, and Jenkins would automatically pick up the code and deploy it onto the production environment, that's called continuous deployment. And once the application is deployed, the ops team would do continuous monitoring, and the whole process repeats as part of the DevOps lifecycle. So unlike traditional approach where we improve the software in one large batch, in case of DevOps, updates are made continuously, piece by piece, enabling software code to be delivered to customers as soon as it is completed and tested. And obviously, since we're not integrating huge chunk of changes in one go, we're not going to have as many conflicts. And since the fact that tests are performed almost immediately after making a commit, developers would get instant feedback if there are any issues with the code. And so they have ample amount of time to address the issue without reaching the end of the development cycle. So every time somebody makes a commit, we're going to repeat the entire process again. And because of the fact that everything is pretty much automated, this is going to be very quick. And Jenkins is at the center of the entire process and is sort of connecting all the dots together. Next, we're going to have a quick summary on what we have accomplished with DevOps. Let's talk about some of the advantages of DevOps. Improved collaboration and improved culture. Obviously, with shift in mindset and incorporating certain cultural philosophies and practices, along with collaborative tools, we have significantly improved the collaboration between cross-functional teams and the overall culture. Faster innovation and issue resolution, with a lot of emphasis on automation and with continuous integration and continuous delivery, we have significantly reduced the time it takes to release the software. And due to these faster iterations, we can innovate faster and also resolve issues in timely manner. More stable operating environments. With the use of various tools and technologies, we were able to create stable environments across all the teams. So if the application works in one environment, chances are that it will also work in other environment without causing any trouble. Less scope for issues and downtime. By consistently performing frequent and regular automated tests and also being able to maintain stable and reliable environments, we can reduce the odds of occurrence of issues or downtime during production. Better operational efficiency. By using various tools like Ansible for configuration management and by using monitoring tools like Nagios and with better collaboration with other team members, we have improved the overall operational efficiency as well. Cost effective. Obviously, with a lot of emphasis on automation, what used to be done manually are now automated. And also by using cloud service providers, we're going to significantly cut the costs. And that's why if you're coming from testing or IT ops background, you need to seriously consider upgrading your skills to DevOps. Customer satisfaction. Obviously, when you follow DevOps methodologies, given all its benefits, ultimately it's going to result in better customer satisfaction because they don't have to wait for releases as long. And obviously that translates to better revenue and better reputation, and also will help you stay ahead of your competitors in the market. I hope you have understood the overall picture of DevOps. I'll see you next. If you like this video, you should also check out my other video which is on the same topic. Link to that video is in the description below. Make sure you watch it. I've also kept some useful resources on this topic. Again, you're going to find them all in the description below. But before you leave, do like and subscribe. The current subscriber count of this channel is embarrassingly low.
and this channel is really struggling to take off despite putting a lot of effort to create good content. It only takes a couple of seconds for you to like and subscribe. I don't really expect you to share this video because I understand it's a difficult task to do, but if you do it as well, it helps this channel and keeps us motivated to bring you more quality content like this. I'll see you in my next video. Have a great day ahead.